Today's lesson on forming simultaneous equations and then solving them. So this is quite common in the exam, that they don't give you two equations and say, here's some simultaneous equations, solve them. So you're not told explicitly in the question that that is the topic. But you're given some information and you're expected to write two equations and then solve them simultaneously. So in this first example, two families go to a pantomime. The Khan family of 2 adults and 3 children pays £71, and the Lewis family of 3 adults and 5 children pay £112. Work out the cost of an adult ticket and the cost of a child ticket. So we've got two unknowns here, an adult ticket and a child ticket. And that's what should make us start to think about simultaneous equations. So from the Khan family, we've got 2 adults and 3 children, and they pay £71, and I'm going to call that equation 1. And then the Lewis family, there are 3 adults and 5 children, and they pay £112, and I'm going to call that equation 2. So both of my A's are positive, both of my C's are positive. So this is looking like a difference model. But I don't have the same magnitude of A's or C's, so I'm going to multiply, and I'm going to need to multiply both equations. I could make my A's the same, I could make my C's the same. I'm going to go for A's, so I'm going to multiply equation 1 through by 5, so that's going to give me, through by 3, so that I get 6A add 9C, and that will equal 213. So that's equation 1 multiplied by 3, and I'm going to call that equation 3. And then to get a 6A again in the second one, I'm going to multiply through by 2. So that's equation 2 multiplied by 2, and I'm going to call that equation 4. Okay, so I've got my greater amount of C in the second equation, so I'm actually going to rewrite this now. I'm going to change the order just to make my workings a little easier. So that second equation, equation 4, I'm going to subtract from that equation 3. So that's equation 4 subtract equation 3. So 6A subtract 6A is nothing. 10C subtract 9C is C. 224 subtract 213 is 11. So I now know that C is 11. I'm just going to write that up there because I'm now going to get rid of some of this working so I can finish off and do my substitution. Okay, so I'm going to substitute into equation 1. So substitute C equals 11 into equation 1. So I'm going to have 2A add 3 lots of 11 equals 71. That's 33. So I'm now going to subtract 33 from both sides, and that's going to give me 38. And then I'm going to divide by 2, and that will give me 19. So a quick check that my answer makes sense. An adult ticket is £19 and a child ticket is £11. That seems like it could be about right. Okay, so next question is slightly different. So we've got a geometric situation here. The perimeter of this isosceles triangle is 52 centimetres. Find the length of its base. So it's quite difficult to see here that this is going to be simultaneous equations, but we do have two variables. We've got an x and a y, which we're going to need to find to be able to find the length of this base here. So that is what suggests simultaneous equations. Now, I'm then going to need 2 bits of information that will allow me to set up an equation. And the first thing I'm told is that perimeter of the isosceles triangle is 52 centimetres. So I'm going to work out the perimeter in terms of the algebra here. I've got 4x subtract 4y for one side, and then another side is x add y, and then I'm adding to that my third side, and I'm told that that is 52 centimetres. So if I collect together my like terms, 4, 5, 6, 7x Negative 4y, add y is negative 3y. Subtract another y, back to negative 4y. And then I've got this add 6. It's equal to 52. Now I'm just going to finally tidy this up by subtracting 6 from both sides. So 7x subtract 4y, and that is equal to 46. And that's going to be my first equation. So where's my second equation going to come from? The other thing I'm told about this triangle is that it's isosceles, so it has 2 equal sides. So I can also say 4x subtract 4y is equal to x, add y. So I'm going to get all my x's and y's on one side. I'm going to subtract an x from both sides, which will give me 3x, and I'm going to subtract a y from both sides. Now that's not going to give me 3y, I'm subtracting another y from negative 4x. So that will become negative 5x, and that is equal to 0. So this is a really tricky question because even to just set up the equations, we are looking at quite a lot of complicated work. So I'm just going to get rid of that work so that I've got some space to solve the simultaneous equations. So I'm going to rewrite my equations at the top here. I had 7x subtract 4y is equal to 46, and that was equation 1. And then 3x subtract 5y, and that was 0, and that's equation 2. So now we can actually get on with the solving simultaneous equations part. And both my x's are positive, both my y's are negative. So again, the signs are the same for each of the variables. So this looks like a difference bar model. Now I am going to make the y's the same this time because that's the negative bit. So it's much easier for me to look at differences between positive things. So I'm going to do equation 1 multiplied by 5. And that will give me 35x subtract 20y. And then I've got to do 46 times 5, which is 230. And then I'm going to do equation 2 multiplied by 4. And that will give me 12x subtract 20y equals 0. So the difference then between these, I'm going to subtract those two. 35 subtract 12 is going to give me 23x. These are the same, no difference there. 230 take 0 is 230. And now I can divide both sides by 23, and that will give me 10. Now, substituting back in, I'm going to go for the second equation. So I've got 3 lots of 10, subtract 5y is equal to 0. So that's 30 subtract 5y equals 0. Well, if 30 subtract 5y is 0, then 5y must be 30. And now I can divide both sides by 5, which gives me y is equal to 6. Very, very challenging, that question. So, your task for today is on the screen. You have got some bits of information here that will allow you to form a pair of simultaneous equations before then solving them, showing your full formal working. The question 8 and question 9, those are the challenge ones. Those are the ones based on geometry where you've got to think about 2 things that are going to allow you to set up an equation. Questions 1 to 7 are more similar to the first example, and I think these should be very achievable. So question 8 and 9 are the challenge. So pause the video here and see if you can set up your simultaneous equations and solve them.